Boys, yesterday you looked at basic trigonometry using the trig ratios, sine, cos and tan ratios. Today we're going to look at some problems where you use those trig skills to solve them. Firstly, angles of elevation and depression, and then bearings. Okay, so again, this is review content that you would have done before. Angles of elevation and depression. Well, an angle of elevation is measured when looking up from the horizontal. To an object. And so that's this angle theta here, up from the horizontal. An angle of depression is measured down from the horizontal to an object below. So here's our horizontal, it's the angle downwards from the horizontal. And if we use alternate angles, noting that these two are parallel, this angle in here is actually the same angle down there. So that's also theta. Let's look at some examples. The angle of elevation of the top of a building from a point 35 meters from the base of the building is 63 degrees. So we've got a building and there's a point 35 meters away and the angle up is 63. So a quick sketch of that, we'll see that we have some building here with height h. We've got an angle of elevation 63 degrees up from the horizontal, and the distance is 35 meters from the base. So with that little sketch, we can use our ratios, and so tan 63 is equal to h over 35. So solving for h, we multiply by both sides by 35. H is going to be equal to 35 times by tan 63, which gives us a result of 25.42. 8. So 2 decimal places. All right, let's look at another. The angle of depression this time of a boat 800 meters out from sea from the top of a vertical cliff is 9 degrees. Find the height of the cliff, correct to the nearest meter. So we've got some cliff and there is a boat 800 meters away. And there's an angle of elevation up to the top, which is 9 degrees. And so again, we want to find that height. So we've got a right angle triangle there, and we can use the tan ratio. And so the tan of 9 equals h over 800. So just quickly backtracking. It said angle of depression from the top, so it's imagining we're at the top here. So if we draw our horizontal there, the turn down is 9 degrees. And that turn down using alternate angles is the same one as that 9 degrees down there. That's how I got that straight away. So solving the same way, h is 800 tan 9. We don't need to actually write that multiplication in there. Still mathematically correct to have it like that. And that gives us 126.707. Blah, blah, blah. Okay, so h is equal to 127 meters. That's the height. All right, moving on. Question 3 has a similar approach to it. You've just got to find the whole distance there. And so you've just got to find this distance and then that distance. So we can have a good look at bearings. I'm just going to give you an answer for this, and you can see if you can get there for this question. So you should get AB equaling 67.81517. And so it doesn't ask you for exactly, so that's an 8 there. So that's approximately 68 meters. So see if you can get that. Just be careful because it's two parts, not to round early. So don't round early. Okay, moving on to having a look at bearings. There's two main types of bearings. There's compass bearings and true bearings. Compass bearings is sort of that common language that we know when we talk about bearings in terms of north, south, east, and west. And of course, they can be split further. So this would be like northeast there, southeast, southwest, and northwest. And we talk about compass bearings as the turn either east or west from north or from south. So I'll give it a few examples later, but it's focusing on how much turn it is from north or south. It's in those quadrants, sorry, from north in those two quadrants of northeast and northwest, or how far south, east or west from south in those two quadrants. All right, true bearings, well, that's the amount of turn from 0. And so north would be 0 degrees, east 90 degrees, south 180 degrees, and west 270 degrees, which then winds us back around to north, also being the point of 360 degrees. So it's the amount of turn from north. So this is the true bearings. All right, let's just have a look at a couple of examples. So what true bearing is equivalent to northwest? Well, a true bearing we want is like 3-figure bearing. So how much out of 360 is northwest? If we go back up to the top here, we can see that northwest is going to be up here. And so that's going to be 270 plus another 45 in there, which would give us 315 degrees. True. Southeast, that's going to be in the second quadrant, 45 degrees further from 90, which is 135 degrees. True. West, well, that's 270 degrees. True. Now let's do the reverse. What compass bearing is equivalent? Well, 90, that's just east. 225 is southwest. I'm just going to give you a couple more examples here. So what if we had 043 degrees? True. Well, as a compass bearing, so I'm just put the compass ones down in the list over here. In terms of a compass, we've got to think about what's the turn from either north or south. So that would be north, 43 degrees east. Here's another, 140 degrees. Well, that's in the second quadrant in terms of the turn away from north. So that's going to be a turn of 40 degrees from south. So this would be south 40 degrees east. Two more, 260. Or 260, that's in the southwest sort of quadrant. And so that's going to be south. How far towards the west? Or 80 degrees west. Because 270 would be another 90 degrees on, which we know is being west. And the last one there, 357. That would be in the quadrant of northwest. So it'd be north 3 degrees west. Okay, so you should be able to figure out any of those true and compass bearings, and they're just needed when you're looking at problems involving bearings. Okay, so let's have a look at this problem. A plane flies from point K on a bearing of 230 degrees for 300 kilometers to point G. Okay, so we've got a point K, and what's often helpful in these diagrams is to draw like a little north grid, and this turn is of 230 degrees in this direction. So that whole turn is 230 degrees, and down to a point G down here. And so the first question asks, what is the bearing of point K from point G? So we actually want the bearing of G of point K from G. So we're actually looking back from here. And so if we draw our north there, what angle is it back towards K? Well, if that's 230 there, then that means that this in here is going to be 50, which means this over here using alternate angles is going to be 50. So we have those two parallels. So that means that that angle is going to be north 50 degrees east, or 50 degrees true. How far west of its starting point is the plane now? Okay, so we want to know from where it was here, how far in the westerly direction. So what's that distance there? So the only thing we didn't include in our diagram to this point was the fact that this long diagonal there was 300. And so actually if I pull out a diagram out of there, I've got a diagram that looks a little triangle that looks like this. I've got 300 there, I've got 50 here, and I want D up the top. And that's a right angle. And so using our ratios, that's the sine ratio. So sine of 50 equals D over 300. And so D equals 300 sine 50, which equals 229.813, which is equal to 230 kilometers. Okay, so let's just have a quick look at a bearings question. Now, question 4 is quite a challenging question involving bearings, and this also involves some three-dimensional trig. And it's all right-angled trig, and the main things you need to use for this question are the ratios, the trig ratios, and you also need to combine that with Pythagoras. It's quite a challenging question. There's not time in this video to do it now, so I'm going to leave it for you to have a crack at, and we might go through it on our first Zoom lesson next week. So good luck with looking at applications of trig with angles of elevation and depression and bearings.